Okay, so today I'm going to show you how to solve an inequality. So this is an inequality right here, graphically. So I've already taken the liberty of graphing the x squared as carefully as I could on this axis. So we'd have a point at the origin, 0, 0, 1, 1, 1, negative 1, and so on. So 2, 4, 3, 9, 4, 16, and 5, 25. So I know in advance that I need to come up as high as 25. So the next thing we would do is graph the right-hand side. So that's going to cross at, let's see, 10, which is going to be right here. And it has a slope of 3. So I'm going to go up 3, right 1, till I intersect the parabola here. So right here is where they have a point in common. And then if I extend this down, right here they will have a point in common. So keep going, slope of 3. So let me try to connect all these points as best I can, because I'm doing it freehand here. So there's the right-hand side of this equation, and the x squared is in blue. That's the left-hand side of my, sorry, not an equation, inequality. So what I'm looking for is where is the blue less than or equal to the red. So here's the red piece right here. So looking at my graph, I can see that this area in here is everywhere that includes a solution where the left-hand side is lower than the right-hand side. So that means I'm going to be going from this point here, which is a negative 2, up to a positive 5. So I know that the blue is below, this blue curve is below the red curve between negative 2 and positive 5. So my solution is going to be that I am between, let me switch back to this color, between and including negative 2 up to and including positive 5. And the reason we know that these are brackets here, all right, these are brackets because I have an equal sign with it. So I could substitute negative 2 into this inequality. I could substitute 5 into this inequality, and it's going to make a true inequality. But anything greater than 5 out here, it's going to be false because the blue switches to going above the red here, and the blue is above the red out here. So going back this way is not going to be a solution to this inequality. So sometimes students like to do that graphically, and just to show you get the same solution, let's look at it the old-fashioned way. Okay, we use some algebra here. So what we would do is set this guy equal to 0. Well, set it less than or equal to 0. And then we factor it. So that would give me an x minus 5 and an x plus 2 as factors. So the only places this would equal 0 would be at if x was 5, 5 minus 5 is 0, or if x was negative 2, negative 2 plus 2 is 0. So I can go ahead and put my points in here, say negative 2 and 5, draw myself a little number line, and we like to mark it this way. So I have one factor, negative 5, or I'm sorry, x minus 5, another factor, that's x plus 2, and then what is the product of x minus 5 times x plus 2? So we're going to figure out where this is going to be less than or equal to 0. So continuing here, I'm just going to pick my favorite number less than negative 2 and substitute it into each one of these expressions. So say I pick a negative 3. Negative 3 minus 5, it's negative 8, but I really don't care. I just want to know that it's negative. If I substituted negative 3 in here, negative 3 plus 2, well, that is also negative. And when I multiply negative times negative, negative times negative, that gives me a positive. So I am not going to be less than or equal to 0 here. So this is not a solution, right? This I can't use. I'm going to put a red X there. Now let's go back and pick our favorite number between -2 and 5. So 0 works really good here. 0 minus 5 is negative. 0 plus 2, that's positive, positive 2. And when I multiply negative times positive, that's negative times positive, we end up getting a negative. So put a negative here. So in this region here, I am less than or equal to 0. So I'm going to give that the green check mark. So that's part of the solution. The last thing we did before we did these graphically is we picked our favorite number greater than 5. So say it's 6. So 6 minus 5, well, that's a positive 1. Whoops. Switch back to the other color. Positive. And then let's see. 6 plus 2, 0.6 plus 2 is positive 8. So positive. And then positive times positive, this is the positive times positive we're multiplying, that ends up being a positive also. So that cannot be part of our solution because, you see, we want this to be less than or equal to 0. So it's not. So my solution is this interval, let me put in a different color, from -2 to positive 5. And again, we trained to use the brackets here because this has an equal sign with it. If this was only a less than sign, then we would have to use our parentheses here instead of our brackets. So checking that with this, -2 to 5 inclusively, and when we do it the old-fashioned way, -2 to 5 inclusively. So some students prefer to do algebra. Some students like to use, graphing calculator or maybe even Desmos. But anyway, let me know what your preference is in the comments down below. And if you got value from this, go ahead and share it with a classmate and give it a thumbs up. Do appreciate it.